All right, so welcome to today's Sec 4 WA2 Online Revision with me, Teacher Jason, over here. All right, I know there's another Jason, so just to specify, I'm Teacher Jason Yek. All right, there's another one in bio, if I'm not wrong. All right, so just make sure you're in the right one if you are revising math. If you're not, please make your leave. But I do know that you guys have actually enrolled lah. Okay, so before I get started, maybe for those first timers who have only never heard of Overmark before, just let me give a brief intro on what Overmark is. All right, in this case, before I get on to the revision for today. All right, so before I introduce Overmark, okay, just a brief intro on myself. I am Teacher Jason, Mr. Jason Ye. All right, so as you can tell, based on the subject I teach, I'm covering all sorts of math, which in this case covers the specialty for today, E-math over here. All right, so mainly I graduated with a Bachelor of Science in Honors in Mathematics. That's why I'm a math teacher, link. All right, I've been teaching since quite a while, for 6 years, but just recently came into Overmark. So for those who are in Overmark haven't seen me before, yeah, that's why you realize I'm starting to appear a little bit more. Okay, so for those under my care, okay, I would say about 70% of them actually achieving B3 and above. But of course, this is due to the two-way communication that I actually enforce. I believe most of my students will agree with me as well. All right, fun fact, all right, you realize me kicking the air. All right, this is what I usually do for photos and also for my own free time. All right, I don't spend math TYS all day. Okay, not just A math, like E math or sort math. Okay, now back to context over here. Also, all right, my credentials at the top is not really just say, oh, okay, I only get B3 and above. All right, these are legit texts from the students them as well, and there are actually more, but I cannot really fit them. So I just fit in some over there to show that they've actually improved for certain grades, which I will not review the message history. It might be a little bit long. Okay, now back to the context over here. So Overmark here, we are quite I would say rather huge tuition center, housing about 1,000 students already within 7 locations, and I'm over here mainly housed in Jurong East and Bukit Timah. All right, so I'll share more info on that later. 8 branches already. So if you are aware also how you get to know this WA2 is through the Telegram, IG, or sometimes even YouTube. All right, where we are actually promoting this particular online revision for you guys to get your last minute cram or last minute pointers for your WA2. All right, and yeah, so most of them from NUS. In this case, I am from NUS as well. NTU for other graduates. Okay, 70% over here. I would say this number is not so much more of I conduct a magic on you and you get 70%. No, it's more of a two-way communication over here that we actually enforce. Okay, and also even though I'm not from MOE or Learning Lab, but I do have other teachers from Learning Lab and MOE who have guided me to be able to be here and guide you guys later on. Okay, we do have a very nice learning environment as well. You can even come to our classrooms or even our site if you feel like studying, whether if your site is a little bit noisy or what's not. So these are the little perks if you're enrolled to Overmark. So let me publicize a little bit here, yeah? Okay, and yes, not only that, as mentioned, if you're enrolled over here as well, you do have curated notes and other stuff as well. So you have weighted assessment revisions and basically notes that actually has been discussed with our own team. I don't operate on my own. I do have a team. And also other stuff like mock exams and more for math, okay? Math don't have practical notes and hands-on unless MOE decides to do a math practical, but that's besides the point. And sometimes if you all need cheat sheets may be available as well. All right, so any questions down the floor before I begin? All right, looks good. Yeah, so just prepare your stuff and I hope you guys are ready for the revision for today. All right, so today we are actually enforcing on this topic known as, all right, let me just adjust a little. All right, today we are enforcing on this topic known as matrices over here. Now, actually, matrices, it's a rather, I would say, small topic, all right, whereby definitely not much marks are within the paper itself, but somehow or other, whether it's paper 1 or paper 2, definitely will come out 1. Whether it's a short question or long question, paper 1 or paper 2, definitely will come out. And in the form of a real world context. Okay, I hope you guys are aware what I'm trying to say, yeah? Okay, so this is where the first part of it, I will say in about 10 to 20 minutes, we are gonna focus on the basic parts of matrices, which I need you all to get. Thereafter, we are just going to venture into, I believe, just 3 questions, okay? Then you can share your thoughts with me as well, all right? To whether you all understand or not, or maybe a two-way com to make sure that you can get some feedback. And yeah, that's about it for this matrices for today. So in this case, literally, we are going to focus on one topic, matrices, and let's begin. All right, so what is a matrix? So matrix in summary, okay, rectangular numbers is what you know, but just make sure you know what is your row and what is your column. Okay, so things to take note. Rows are stuff that are actually arranged in the horizontal manner. All right, and my columns are arranged in the vertical manner. Okay, each one of them is known as an element, but usually your elements, it's either can appear in 2 ways. One is actually your variables or your x and y's. All right, number 2, it is just your normal numbers. Okay, your variables or numbers that can be written in the box, all right, you can determine from there. Okay, now from here, this is very, very important later on as we move on to multiplication. You need to know the order of the matrix, all right? In this case, the size, because we know certain matrices cannot multiply together, depending what is multiplied by what. Okay, so what's the order of the matrix over here? All right. Order of any matrix, I say is the number of rows to the number of columns. And take note, all right? This multiplication sign just means, like, follow your dimensions, something by something. We do not multiply the numbers together. So very important note, okay? Now, these questions over here seems very basic, but as I mentioned over here, these are very important for real world context questions, all right? Basically, your giveaway marks, especially when they ask you to list a particular question. Okay, you don't have the worksheet. Okay, give me a moment, yeah? Okay, you should have the worksheet with you by your side already. So you can go to our website, okay, or the link. It should have the worksheet link over there. Okay, yeah, just try and check for your side. All right, Jaylene, if I'm not wrong. Okay, just give me a moment. Let me divert a little while for good. Yeah, just go to our website. Yeah, it should have our worksheet there. If don't have, let me know. Yeah. Okay. All right. So find the order of the matrix. Okay, I am going to just list a few. You guys are gonna prompt me for a few ones. Now, first one over here, very simple. 2 rows, 3 columns. So therefore, my size over here will be a very nice 2 by 3. All right, straightforward, right? Okay, and we know 2 by 3. And in this case, my next one over here, 3 by 2 are totally different. Okay, so can anybody tell me for part 3, what will be the order? All right, just type it out. All right, shouldn't be too much of a hassle. All right. All right, awesome, Tanishka. All right, so we have a 3 by 4. What about the last one? All right. Awesome, Troy. Awesome, Tanishka. I have a 1 by 4. All right, so we know 1 by 4, we can justify as a very special matrix over here. All right, so guys, just give me a little while. I'm going to send the link for the WA2 material for uh give me a moment, yeah. WA2 material for Jaylene. All right, just give me a while, okay? All right, so just let me do some parts first. All right, just give me a while. Okay, next time, just remember to download the material, yeah? But it's okay. I'm gonna send the link through to you now. All right, just make sure you receive it at your side. Okay, all right. So sorry for the disruption. Let's move on. Okay, now what happens is this one over here, part 4, is actually a very special type of a common matrix that we know, which I'm going to go through right now. So these are some common matrices that you will see as we are actually talking about in the table below. So more common ones, all right, is actually maybe they might actually ask you, oh, express it in a row matrix, express it in a column matrix. All right, how do we actually know how it looks like? Very important. So row matrix, all right, an example, exactly one row. It must have one row, but how many columns? I don't care. So it can be any number, and n must be a positive whole number. All right, cannot be zero, positive integer, maybe more exact. All right, Jenny, if you manage to access the material, just throw me a thumbs up, yeah? Okay, so can anybody just throw me an example of a row matrix to see whether you guys understand? Okay, it's a very simple one. All right, don't have to be too long, yeah? Okay, I don't need a very long row matrix over here. Just type it out. I'm going to give you some time to recap your concepts here. Awesome, awesome, Tanishka. Thank you. So 2, 3, 5 is one of them. Okay, or any other more want to try? Okay, so thank you, Tanishka, for being participative here. Not saying the rest are not participative. You might be in a circumstance that might hinder you to write. But basically, a row matrix is literally having one row. Any columns doesn't matter. All right. Similarly, if I move on to my column matrix, n times 1, all right, it's just basically how many rows I don't care, but my column is a one column down. Okay, so even though you realize my entries are different, these two are not equal. We are going to go to that, as you can tell, at the next part. Okay, square matrix, all right, third one, matrices with the same number of rows and columns. It's just saying that if I have n rows, the other one is n column. One good example over here, I know it's hard for you all to write, therefore I'm going to write for you all, 5, 1, 3, 4. This is a square matrix, all right, because it has 2 rows, 2 columns. Okay, last one. I'm going to test you all. Can I define a formula, or in this case, any specific order for a zero matrix based on my description over here? All right, yes or no? All right, Y, type Y for yes, and for no. Okay, I have yes. Any other people want to try? Is it yes or no? Only 2 responses. Okay, doesn't mean it's wrong, But, Jenny, are you able to access the material? Okay, so I think I have any other responses? No worries, no worries. All right, all good. Okay, in fact, this one, the answer actually is there is no specific formula. Why? Because a zero matrix, I'm going to give a few examples actually. A zero matrix, no worries, all right, is mainly a question that I feel we tend to ignore, but it's just an insight. Okay, so I'm going to give a few examples, all right? So I 0, 0, 0. So this is a zero matrix, all right? This is also a zero matrix, but you realize it doesn't have any pattern or specific order that I can write it down. Okay, so just take note. This is for you to take note. I believe they won't ask you any questions on, oh, what is the formula for a row matrix, column matrix, square matrix? All right, not so much for the context for today. Okay, all right. Okay, so moving on. First one, typical question, equal matrices. All right, so I say they are equal. All right, for one, the size must be the same and all the elements are identical. All right, no problem. All right, are you still taking note down this one? All right, if you are taking notes, let me know, yeah? Okay, I think I paused a little bit. Awesome. Okay, if the same order and all the corresponding elements are identical, basically playing your positions, in this case, very important. All right, so what am I talking about? In this case, if I say P is equals to Q, first note they are equal because the size are the same. Both are 2 by 2. All right, secondly, all right, if I say they are the same, these two things have to be the same. And then if I color code, let me color code the correct ones. Okay, so in fact, I'm playing with their positions. Okay, not gonna read all the alphabets, but you guys get the idea. Okay, noting the color coding over here. Okay, essentially all of them are the same. If you understand this node over here, all right, if I talk about addition and subtraction, all right, specifically the way we add stuff, it's the same as how you add or subtract numbers. Just that, okay, there is a particular rule set to follow or conditions. Firstly, they have the same order, same size. All right, cannot have the big one minus the small one or big one at the small one. Secondly, all right, the last matrix will also have the same order. So what do I mean? So if I were to add both of them correspondingly to these numbers, it will be this way here, following up nicely with the pink and the gray. And this idea will also hold the same way when I talk about subtraction. Okay, so quite straightforward. That's why I'm moving quite ahead a little. But anyone still have any doubts on this? Yeah. All right, let me move on. So third one, scalar multiplication. This one will be the easier one before we actually move on to the last part over here. Last recap, matrix multiplication, where things get a little confusing. Okay, what do I mean? Third one, essentially, what's a scalar? Scalar is just a number that's outside a particular matrix. If I have a number outside the matrix with all these other elements over here, I'm essentially just having all of these yellow color elements, all right, being multiplied by k, right? This one, straightforward. Okay, now, last part over here. This is where I'm going to slow down a little in terms of my explanation, and I'm going to actually explain what it really means. Now, this is where I mentioned just now why the order is important. All right, because I can only multiply two matrices together if and only if, all right, that's the thing, if and only if the number of columns, in this case, on my first matrix, aka you can say this is the left-hand side matrix, equals to the number of rows in my right-hand side matrix. Okay, and this is actually justified by the formula there. In this case, I'm literally saying that these two are equal. Therefore, I can multiply them. But now, how does the multiplication work? Okay, so let's say, all right, based on this formula, okay, I'm going to piece it for you all. And using one example, suppose I want to know how I'm getting this particular entry here. Okay, so we call this one over here, I hope you all realize, this entry is specifically saying it is at the first row and the first column. Okay, now why am I writing it in different colors, you may ask? All right, because to get this particular matrix, literally to get the position of my resulting multiplication, I will need to multiply the entries at the, all right, first row. Okay, I'm going to use the correct colors. All right, so let me do it here on the first row to the first column. Okay, I'm going to use this one here. So think about this way, row by column, multiply them, and essentially think about like pairing up, okay, finding a pair to do your project work, all right? Let's say you're doing project work, you need to work in pairs. This is saying that you are finding your pairs in this particular context. First row of the first matrix, left-hand side matrix, to the first column of the second matrix. So when they are doing this, first row, that position, left-hand side. This one, right-hand side. If you understand this context, all right, the rest of it will flow smoothly. First row, second column. Okay, let me annotate for the first row, first column, yeah. Next one, I'm going to use another color. Second row, first column. So it's always left-hand side row, right-hand side column, huh? Okay, I hope you all see the pattern. So I'm going to have second row, first column. Afterwards, second row, second column. Okay, you all may ask, teacher, will this only work for 2 by 2? Answer is no, it will also work for other matrices provided this condition holds. All right, what do I mean? All right, last style recap already, yeah, before we go on to certain questions. Okay, so I don't want you all to tell me whether we can, what's the answer first? Part A, all right, let's investigate together. Am I able to actually evaluate part A? Yes or no? All right, anybody want to try? Yes or no? Okay, let's see your responses, see whether you understand or not. Okay, why? Yes, no. All right, can I have some response? Can switch? Good question. All right, we cannot just randomly switch. Matrix multiplication, I cannot anyhow switch my matrices. Because if you switch, the way is different. So good question over here, Tanishka. You cannot switch. Cannot. Okay, so good learning pointer. No, no. So I cannot say part A, it becomes this. This is not equals to this. No. Okay, I have one answer. Any other answers? All right. So actually, my first matrix is a can evaluate. Why? That's why I mentioned at the start, your order of the matrix is important. Very good, Jasper. Left-hand side is 1 by 2. Second one is a 2 by 2. Is the number of columns on my right-hand side equals to the number of rows on my left-hand side? If they are equal, important thing to note, what is the final order? Final order of the matrix very straightforward actually. We take the two extreme numbers, we piece them together. No worries, Tanishka. That's why we learn together. Glad that you are having the replies. We piece them together. We know our end will be a 1 row, 2 column matrices. Now, how do we evaluate? Okay, first things first, write down our matrix as if it was given from the question. Okay, so we know now our end goal is that we have a 1 by 2 matrix. Now, how do we go about getting our final matrix? So we know 1 row, 2 column. So in this case, only 1 row, but 2 columns. Only 1 row, but 2 columns. So take note over here okay, I have misjudged my matrix wrongly. So 1 row, 2 columns. So let's judge. Okay, I want the first row, first column. So where do I get the entry from? First row, first column. Okay, so don't worry, JD, let me explain again. Okay, so let me repeat again. This one we can matrix multiply, first things first, JD, because number of columns on the matrix here, which is 1 and 5, is equals to the number of rows in my right-hand matrix. Number of columns at the matrix here equals to the number of rows in the matrix here. From there, if you want to find the final order, since these two numbers are the same, I don't need to care them. I take the n numbers, I put them together. This is the resulting matrix size. Is this clearer now? Why is the row same as column? Because what's the number of columns here, Jaylin? 2, right? Left-hand side is 2. What's the number of rows here? Also 2, right? Are they the same? Take note, I'm comparing between two different matrices. I'm not saying the number of rows of the matrix. I think I know where you're confused at. You're confused why I'm saying that this one, why am I saying number of rows and columns are the same? Am I correct? So I'm saying both matrices, okay? Rows on the first matrix, columns on the second matrix. All good? Okay, can so that's why you realize even though this is rather fundamental, I'm still going through slow because it will build up. Awesome. Okay, so right now, back to the context. First row, first column. So this will be at first row, first column here. So when you matrix multiply, first and last number, that's right. That's the final size, Jaylin. Okay, so from here we have 1 minus 1 plus 5 and 8. Okay, this is basically the first row, first column. Okay, now, those working here, if you're familiar, you don't have to do it, okay? Next one over here, first row, second column. I realize I need longer. I need a longer bracket. So that's why I'm erasing it. Wait, So next one, first row, second column. So that's why as a result, this is the matrix. Take your calculator, press it. You can mental sum, go ahead. Just make sure you do it correctly. This is a matrix multiplication. That's it. Okay? Yeah. So that's why as long as you know the positions of the resulting matrix, this one represents for the left-hand side, this one represents for the right-hand side, you will work it out accordingly. We will practice a lot of that later, so don't worry. What do you use it for? Later on. This is mainly for evaluation, Jaylin. Okay, so for now, we are evaluating, but later on when we see questions, you will understand what we are using for. Okay, in real-world context questions, we mainly use it for evaluating what the elements mean. You will see later, got 2 questions. Don't worry, I got prepared, so don't worry. Okay, can I move on? Let me move on. Okay, now, part B. Any questions first? Seems like this chat is getting active. I love it. Yeah. All good? Can if good, drop thumbs up. Or if you say if you are okay, just type okay. What do you mean why, Jaylin? How you know what to multiply together? So let me repeat again. This is your first row, first column, right, of the resulting matrix. So the row part, we always refer from the left-hand side. The column part, we always refer to the right-hand side. So that's why first row, first column, when we pair it, the first number will always get paired to this. The second number will always get paired to the bottom number. One goes right, one goes down. Okay, is it clearer? Awesome. All right, any other questions? Okay, so that's why I want to clarify. Okay, that's why my description is a little faster. For those who actually took my class, I actually used one whole lesson to explain matrix multiplication. So I might actually skip certain details here. Yeah, awesome. All right, now part B. Can I matrix multiply? Can I evaluate part B? Yes or no? Anybody wants to try? Awesome. All right, awesome, awesome. Good. Thank you for your response, Troy. Any other responses? Awesome, Tanishka. Any other responses? Yes or no? Just type it out. Okay, I'm actually seeing your responses. Okay. Okay, so answer, all right, we do know it's a no, but how to explain? All right, for those who answer, that's good, you know it's no, but how to explain? All right, so we just have to explain in this case in this manner. Rarely they will ask, but you really just to explain explicitly. Number of columns in my left-hand side matrix is a 1. Number of rows in my right-hand side matrix is another 1, which is 2. Okay, we know they are different, so therefore, this is not equal. I repeat, not, no, no, all right, equals to this. Therefore, does not exist. Okay, that's it. Okay, so these are certain things that you need to know. Usually won't explicitly test, but something that should be ingrained in your head before you start matrix multiplying. Okay, all good? And okay, can I move on? Okay, I will wait for about maybe 5 to 10 seconds before I move on to the questions for today. Question, there is 2 rows. But for your answer at the top, there's only 1 row. Yes, that is right. First matrix we call, what's the size? 1 by 2. Second one is 2 by 2. Resulting matrix, left-hand side, only 1. Right-hand side, 2. That's only 1 row. So you can picture it. How you form the resulting matrix, once you realize these two are the same, they have done their job. Okay, these numbers can disappear. That's why 1, 2, they get together. Awesome. All right, any other questions? Okay, so that's why matrix multiplication, I'm going through rather slowly. Okay, in fact, I would say I'm explaining rather quickly already. Yes, 1 row, 2 column. Okay, let me backtrack a little. You might have missed out the first part. Recall when I talk about size is always, don't switch my numbers. Rows on the left-hand side. Okay, rows on my left-hand side, columns on my right-hand side. And okay, that's why at the start, remember I said order important, even though it's straightforward. Okay, any other questions? And before I move on, hint. Okay, now, awesome. Okay, so this is a first style of questions whereby you have a normal algebraic manipulation, but emphasizing more on matrix multiplication. Then after that, normal operations. Okay, so this one, equal matrices, find the values. See this one, you have 2 matrices multiply. I won't evaluate too much. Literally, just take your matrix and you matrix multiply. Okay, so first, what I would like to do, you copy and paste the question down. So 1, 0, 4, 5, 2, minus 3. All right, and then you have 1, 2, 8. Okay, equals to 8 and B. Okay, so what we can do, so we call your steps, okay? Usually when we want to solve, we will simplify our equations. So in this way, or in this case, I'll simplify my left-hand side first. All right, so we call what is our resulting matrix. Okay, first one. Okay, 1 by 2. Second one, 2. Sorry, not 1 by 2, sorry. I cannot count. 1 by 3. Next one is going to be, not 1. Oh my God, I really cannot count. 2 by 3. Next one, 3 by 1. Final size will be a 2 by 1. So it actually matches the one on the right, which makes sense. Okay, because remember, equal matrices, my size has to be the same. So when I evaluate, take note, I want the first row, so take note. This one is telling me I have 2 rows. This one is telling me I have 1 column. So therefore, 2 rows, 1 column. All right, so make sure you draw a bit nicely. Okay, I want first row, first column first. So it will be this one multiply with my red color one. 1 times 1 first gives you 1. 0 times 2 gives you 0. 4 times A gives you 4A. This one will directly give you the entry right here. Okay, I'll combine the matrix later. I'll write down the size later. Okay, the other one. All right, same thing. Second row, first column. Second row, first column. Second row on the left, first column on the right. 5 times 1 first, 5. 2 times 2, 4. Negative 3 times A, negative 3A. Combine, and your matrix multiplication is done. So from here, all we are essentially doing is once we have equal matrices, we just compare them. First one, 1 plus 4A equals to 8. All right, evaluate A will just be 1.75. If you want to leave it in fractions, up to you, both works. Yeah? Okay, it will work too. Then if I want to find B, okay, I'm going to shortcut a little. It's just going to be, in this case, 5 plus 4. Sorry, no shortcut. Minus 3. That's where you substitute your number in. Take your calculator, press it, answer 3.75. Again, fractions also work. Okay, so this is where I'm just emphasizing a little on matrix multiplication. But hey, this works, okay? Even though quite long ago, but it still can appear. And give you all some time to absorb this. Any questions, feel free to drop it down. And I'll wait for maybe 30 seconds before I move on to part B. Yeah, all good. If any questions, just write it down, okay? I'll be more than happy to answer them. Awesome. All right, now part B. Essentially, just evaluating P square. Okay, now P square doesn't mean I square each of the entries by each of the entries. That means not, I don't do this. Take note. Please don't do this. It's not 1 square, 2 square, 4 square, 3 square. This is not your P square. Very careful. This is not your P square. Okay, P square just means P times P. And we know matrix multiplication works differently than just squaring your numbers. Okay, so when we are actually doing the matrix multiplication, write down explicitly. Okay, what do I mean? Okay, if you refer, P is 1, 2, 4, 3. Okay, Q is the other one, not so much of a concern. When we do P square, all right, just write both P separately. All right, what do I mean? Okay, I have 1, 2, 4, 3. 1, 2, 4, 3 plus this. So this is what I mean by write down explicitly. And you'll realize if I do it this way, though more tedious, but when you're doing your matrix multiplication, all right, row, column, I'll leave it up to your calculator work. 1 times 1 is 1. 1, 2 times 4 is 8. Add these two numbers, you get a 9. Okay, this is for this entry here. Okay, let me read Chloe's question. A 3 times 1 matrix in first term represent change in x-axis. Oh, okay, this one is a little out of scope. Okay, so I'm not too sure why your teacher is going through this based on your question, but you will have this thing called the z-axis. Okay, this is out of syllabus, yeah, because you have xy. Okay, xy like this, yeah, so you're reading it horizontally. The third one will actually represent your z, so basically the one top up, more for 3B. Okay, maybe this is more of a food for thought, but don't worry for the rest who are listening, there's no such thing as z-axis for your secondary side. Okay, I hope I got your responses, Chloe. And okay, interesting question, but yeah. It's an interesting question, but I don't it will not come up for your stuff. Why 9? 1 times 1 plus 2 times 4, Jaylee. Remember matrix multiplication? 1 times 1, I pair. 2 times 4, I pair. So I add them together. All right, take your calculator press, unless you type 1 plus 9 somehow. Just be careful. Again, next one with my numbers again. Oh my god. Okay, this one. The other one is going to be 1 times 2, 2 plus 2 times 3, 6. Okay, 2 plus 6, that will be a wonderful, nice number, 8. What? But Chinese New Year gone already. Have to wait until next year. Okay, and JD, okay? Okay, awesome. All right, third one, I'm going to use pink. 4 times 1 is 4. 3 times 2. 3 times 2. 3 times 4 is 12. 4 plus 12, 16. Okay, so in this case over here, this is a very wonderful 16. Okay, last one. 4, 2, 8, 3, 3, 9. 8 plus 9, 17. Okay, so this one I kind of shortcut a little in terms of the working because by now I hope you guys are able to do the mental calculations as such. If you cannot, let me know. Okay, I'll do my best to help you out further from there. Okay, next one, very simple. This one is your scalar multiplication. I can just plug my numbers in. -6, 3, 15, 27. Okay? Right hand side, I don't want to focus too much. It's more the matrix multiplication that I want to slow down. Okay? Can After that, if you follow the above and recap a little bit, it's just really subtracting the required numbers. 9 minus 6, put them together, 3. 8, 3, I have 11. 16, 15, I have 31. 17, 27, I have 44. Okay, so this is really it. That's it. Okay, the most important thing you realize I emphasize a little bit much more is really, really the matrix multiplication. Okay, take some time, analyze this. Any questions before I actually move on to the main, not main, but the more common style of question that will come about. Okay, I'll give you all about, I'll zoom up to the whole picture. Give you all about maybe 30 seconds more to look at this. Awesome. Now, moving on to the main bulk. So usually matrix questions won't come out in such a nice manner. If matrix questions come out in such a nice manner, please bless your teacher, say thank you. Okay? What type of questions will actually come out? Will be more common. Jing, jing, jing. Got extra page, right? So this kind. So definitely viewer context. We know they like to play different contexts. They will give you a lot of info. They will ask you a way to actually put in matrix form. And I'm going to share you certain tricks. All right, to how we tackle this kind of matrix questions. Okay, got some minor hack one. Okay, yeah. Now, a lot of questions, a lot of things written there. But let's just analyze first, okay, and see what it means. And in this case, real context, the information is very important. Okay, in this case, this tells me a gift company, 3 hamper packages of biscuits, bar of chocolates, and bottles of wine. Knowing the info in the question, packet of biscuits is this, bar of chocolate is this, bottle of wine is this. All the info here, and in this case, they classify nicely in the form of matrices for you. So usually this type of questions, the table and the matrix written are related. Key thing, related. Because if you look at the questions, I think most of you will struggle at this part. What does it represent? How do you actually write the statement down with all these numbers? Because when you matrix multiply, okay, all right, you realize there's no meaning to write it. But now there is some meaning. All right, I give you all these numbers. It means something here. But matrix doesn't really tell me anything. How do I do so? Okay, so that is where the head comes in. Okay, and then you realize my numbers here, yeah, comes into play over here. So I want you all to take note. Important numbers because it's specified in the question. So I'm going to play with colors. I love colors. Okay, there we go. Okay, so now, first one, evaluate the matrix R equals to HP. Okay, so this one, okay, really is just matrix multiply lah, like what we did just now. Follow the question, free 2 marks lah. Okay, give me a moment, my pencil decides to disconnect again. Okay, let's hope it resumes again. Okay, yes. How to evaluate R? First, identify what is the matrix H. 6, 5, 3, 9, 7, 4, 10, 8, 12. 2, 2, 2, 2, 2. Second one, 7, 2, 0, 10.8, 32. Okay, after that, just matrix multiply accordingly. But one thing to note, okay, always try to predict the future. In this case, what I mean is predict what is your, or know, not even predict, know what is your order of the resulting matrix. How big is it? This one, we know it's a 3 by 3. This one is a 3 by 1. Okay, the numbers at the left and right respectively we have circled. All right, we take those numbers. Your final size will be a 3 by 1. But don't assume, please always check first. These two numbers here are the same. No, the question will always assume they are the same. So I just take the left number, right number, multiply. Who knows, they may trick you. So always check. Okay, once we have this, now that's why we multiply. First row, first column. Yes, middle must be the same. Always the case. This is, even though we will context, remember Jadine, always remember matrix multiply, your middle number must be the same. So in this case, left and right lah. Yeah, something like that if I've interpreted your question correctly. Okay, so when I do the first part, row there, column down. Okay, I'm not going to write the whole thing. It's a little long. So you just take 6 times 7.2 plus 5 times 10.8 plus 3 times 32. All right. Different thing. Okay, Chloe, for matrices with powers, right? You will not deal with negative numbers. Okay, this is out of context. Wow, I love all your questions today. Okay, this is a little out of context. Because when we talk about matrices, right? When you talk about this one, okay, it actually means what we call inverse. Okay, not out of context. Since Chloe asked me the question, I will share with you all. Okay, this means inverse. This is not this. Okay, this is not this. These are two totally different things. So for negative numbers, don't work. For positive numbers, 2, 3, 4, you have to write it out explicitly. Okay, have I answered your question? Awesome, awesome. Okay, so be careful. But usually for matrix multiplication questions, I believe they won't give negative powers. So you don't have to worry. Okay, so that one, they won't give negative powers. So you don't have to worry. Okay. All right, I love your questions. You know what? I'll leave this here. Love it, love it. I love it. Okay, now just multiply my numbers as mentioned just now. First one will be 19.20. Second one, do the same thing. All right, let me color code nicely. This is my pink. This is my yellow. Next one, second row, first column. So second row, first column, 9 times 7.2 plus 7 times 10.8 plus 4 times 32. Take these numbers, add them together. You get 268.40. Last one, 10 times 7.2 plus 8 times 10.8 plus 2 times 32. This will give you 222.40. Okay, with my color codings, let me color code. Okay, last one, let me use a nice color. Okay, green. Okay, this will be the matrix that I have. 2 marks. Okay. Now, the second question will be the harder one, because it will always come in pairs on these two. Once you evaluate, they will always ask you, what do the elements represent? And sometimes it takes too much time. Okay, always remember in exams, your gauge is 1 mark, 1.5 minutes. Okay, but this type of question is really putting a trick there for you to actually say, wow, you need to read from the table, you need from the info, and then you try to decipher. By the time you do that, I think more than 1.5 minutes. Then you may ask, you say all this to demoralize me. Is there a trick? That's why you are here, ma. That's why I'm here to share. So there is a trick towards answering this type of questions very, very fast. So this is where I need you all to try to open your ears, lift up your antenna. I do that in my class. Lift up your antenna and listen up. Realize how the info in the question are put according to the table. It's literally copy and paste, right? So can I actually just say my info is just copy and paste, where in this case over here, I have hamper A, B, C, biscuits, chocolate, wine. Okay, just copy and paste from the table. The other one isn't really given in the table, but that's why I asked you all to highlight. That's why I highlight just now. Biscuit is 7.2. Chocolate is 10.8. Wine is 32. Biscuit, chocolate, wine, and we know all these other costs. Okay, I'm just listing the information there. There is nothing new I'm sharing yet. Okay, can see? Okay, can Now, what is the trick here to understanding this type of questions? The trick is, do you see common letters? Okay, in this case, okay, let me label it a bit different. The C and the C we know is different. Okay, chocolate, I put CH, okay? So BICHWI. BICHWI. Now, I think you guys know what I'm trying to lead to. Okay, do you realize there are common things written down there? Okay, look like elements in the periodic table, but they're not. Okay, you realize there is one BI on the here, BI here, BI on the here. CH here, CH here, WI here, WI here. So this is the main trick. Okay, it will always work. What you can do, these entries that are in common, you remove them. Okay, what do I mean? Because they are in common, so I don't need certain things to be described twice to you. It's like if I need to actually keep repeating the same thing to you all, you also find it sian ma. So if it repeats twice, I don't like it, I throw it away. Now, what do I do next? The one at the column, transfer the info here. The ones at the row, you transfer the info here. So now, this is actually just the info that I need to read from R. Once we have the matrix with all the info like this, isn't part B easy to do? State what the elements of R represent. Cost A, B, C. Done. Of course, you write it in a sentence. Don't write my matrix like this. Okay, so R actually represents the cost of each hamper. And it will always work. It will always work. So right now you realize how long did I take to do this? Maybe if I didn't elaborate too much, I guess a good 30 seconds. Because you're just really copying down the info from the question. Maybe this one a little bit more effort, but I realize what I just did. This three, gone. This one, put here. This one is your row, put here. That's it. That's it. Your whole matrix, the explanation is there already. Do you all see that? Okay, so I hope you all take away something new just from, besides trying to throw away this part B over here, I hope this one helps you a little more. Okay, can when I cancel the food, in this case, you're talking about it, yes. Just remove everything because this is like your intermediate stuff. So you can just remove, take whatever the row means, okay, Tanishka, this one what it means, put here, this one what it means, put here, and you are done, that's it. So you don't have to spend a good 2-3 minutes, I believe, trying to decipher from the whole freaking table where you are just removing the intermediate info, whatever the column is, write it down, whatever the row is, write it down, voila, that's it. Yeah. I'm glad you find that useful. That's a very heartening thing to hear. Okay, what about the rest? Can Sweet, sweet, sweet. Okay, now part 3. Okay, part 3 again, or part C is a giveaway. All right, where you realize literally depend on the info. They want 1 row, 3 numbers. They give you those numbers accordingly. So all we need to do, 1 row, 3 numbers. We write these 3 numbers down. That's it. Okay. I don't think I need to enforce too much. Just from the numbers, copy and paste. That's how matrix questions are. You literally take the info, you dump it in. Okay. Can Now, part D, I would say is the more annoying part. Okay, so this one, I try to see how I can get to you all. Now, if they actually remove this sentence, I believe you all can do, right? Total of 20 is sold, total of 25 is sold, total of 30 is sold. And these are the cost of each hamper. Okay, so ideally what you all will do, okay, I am actually going to type out this response over here. Okay, give me a while, let me type it out. You all will definitely do this, right? Okay, if it's not matrix multiplication, okay, you all will do this. Okay, so I'm going to blast it in the group, don't worry, give me a moment, yeah. I just don't want to type the wrong number. Okay, I believe you all will do this. Okay, you all will do this, right? Straight away, without matrix multiplication. And in fact, this will be the number that you get for the answer. But now, what is the catch? The catch is you have to represent this info or this evaluated number over here, which you type in your calculator. It's a very good 17246. All right, 17246. Okay, and that will be the final answer. Okay, but if you only write this number down, you don't get the full marks. You only get 1 mark. Answer mark lah. Matrix multiplication, how to do? Again, another trick. This number is what you eventually get. Backtrack. I want to have because matrix multiplication, if it's just one single number, 1 row, 1 column. Make sense? Okay, now with T over there, I want to make sure I can multiply these 2 things together. Okay, there are only 2 ways because I work with this. Okay, either you are working with this configuration, or the other configuration. So I'm going to give you some time to think about it. Let's call the top configuration A. Let's call the bottom configuration B. All right, I'm going to give you some thought. Which configuration is going to give this answer here? A or B? All right, thank you, Jasper, for the response. Anyone else? Okay, so I have one response. Okay, 10 more seconds. A or B, quickly. All right, just one letter only. Okay, thank you very much. Which configuration, A or B, will lead me to my one-by-one matrix? Tanishka. Okay, I have two responses so far. Thank you, Jaylene. Okay, how to see? Very good. So most of you all got the one. We know it's part A, but how do you get this answer? Okay, now one thing to take note. Okay, final answer is what? One by one. Correct? We look at B. B is 3 by 1. This one by 3. Final order? Firstly, does the order even match? No, right? Because one is 1 by 1, one is 3 by 3. Therefore, gone, disappear. Habis, I can erase this away. So that's why the answer is A, and we go to double check. First one here, 1 by 3. Second one here, 3 by 1. Combine together my numbers, my order is a good 1 by 1. This one will go to its rightful place. And that's how you use your matrix multiplication. Okay, but don't write in matrix form. Okay, matrix just gives you a number. Good to actually finalize your answer and say total. What are we finding again? Total sales. Total sales. All right, this is a short sentence. For your side, they will give you a blank, but just make sure your blank has the dollar sign. Okay, so I'm gonna zoom out. Okay, I don't know whether you can see the whole working like this, but yes. All right. Okay, I think it'll be hard. Let me zoom to the workings. Yeah, I believe you all have the question. Take some time, look through this. Let me know if you have any questions before I move on to one last one. Okay, one last variation. Any questions? And if you still have further questions later on, I will answer them. All right, but let's move on. Okay, last one. Okay, I thought I'll need more space. That's why I put it here, but I guess not. Okay, last one. Okay, same stock, but you realize it's a little harder because there might be certain changes in the matrix that I'm evaluating. Okay, first one, not so much change, it's just stating. This one, real world context, but I level up, got some change. Okay, what do I mean? Not so much for the first part, okay, but let's write it out. Part A, represent the working hours of the matrix, working hours of the clock by matrix A and the hourly rate. Okay, so in this case over here, info given, table, and whatever info is given. Now, the tough part is this. They didn't even write down the matrix for you this time. Right? But you realize the trick is this. If they give you in the table form, the actual case is we can actually write down the whole matrix and copy and paste. So what do I mean? You realize working hours is related to A. And my working hours are stated in this table here. So, therefore, working hours is A. I am literally just Control C, Control V. Okay, copy and paste from the table. That's it. I'm not doing anything new here. Just copy and paste from the table. But now, second part B. The hard part for part B is I need to make sure AB exists. So let's recall, in order for my multiplication to exist, the number of columns on my left-hand matrix, in this case A, let me write down 2 columns, is equals to the number of rows on my right-hand side matrix here, which is 17246. I did write 17246 though. Oh, thank you, Jaylene. Yes, thank you for the reminder. I even copy and paste wrong, but yes, thank you for the heads up. 24. Thank you for the heads up. Yes, it's 24. Yes, I kind of cross-eye as I copy and paste. I don't know why. Okay, but thank you very much. Okay, now back to the question. Now, part B, over here, the number of rows here has to be 2 rows. Okay, that's one thing. But now we wonder, how do I have my info here written in 2 rows? 2 values. The only way to write it in 2 rows is based on the info 20, 30. So I didn't conjure this out of thin air and say you must learn how to read the information and not. Got trick one. Okay. If given in table, what we can do? Copy and paste. That's the trend of questions. If they need you to decipher the table, I tell you, that means the person need to work on his collation of data. Need to go back to learn more statistics. Okay. Table form, copy and paste. Okay. If info given in the question, make use of what you have. Number of columns for A is 2. Therefore, B should have 2 rows for my matrix multiplication to exist. And that's why I have this. How I know 2 times 2? 2 times 2. Oh no. Number of columns at A has to be equals to number of rows at B for matrix multiplication. So first one is part A, working hours. Your info is written here. Usually info written in table form, we can just put and paste, put in. Now we identify the matrix there. We realize it has rows, I don't care, but columns, I know it has 2. Because I want to know whether AB exists, not BA. So therefore, 2 columns. Henceforth, my B has to have 2 rows, which is stated here. Make sense? Any other questions? Can I? All good? Okay. Part 2 is a giveaway lah. How I get what? 20? Here. From the question. Question will say, the values are all conjured there, are all from there. If not from the question, I cannot take. Very good. Okay, part 2 is a giveaway. All right, because it's literally finding the matrix multiplication. So please matrix multiply 4, 45, 38, 4, 3, and 7. Okay, 20 and 30. It looks weird, but just take note what's the final order. Okay, if you're not sure, you can write it down. If you are sure, no need to write. If you are sure, 3 rows, 2 column, 2 rows, 1 column. Final order will be a very nice 3 rows, 1 column. So, picture. Okay, I want to get my, again, I use the color coding. First row, first column. I'm doing 40 times 20, which is 800, plus 4 times 30, which is 120. Okay, next one. First row, second column. 45 plus 20. 45 times 20, which is 900 plus 90, 30 times 3. Third one, okay, let me color code first. Third one is going to be, where's my highlighter? 38 times 20, that is 5. Let me just calculate first. 38 times 20, it's 760 plus 210. This is equals to this way. After that, we just need to evaluate each one of them. Okay, not gonna focus on too much on this. Okay, I think I repeat quite a few times already. Okay, so add them up, and this will be the answer. Okay, why haven't I finished my sentence? You realize it's because you look at part 3. They ask you to multiply. Confirm is always ask you explain. But now you all know the trick, man. You look at the table, what it represents, regular over time. So I can put R-O. Then the other one is Fatima. Fatima who? Fatima, Vani, and June. Okay, check the bottom one. The other one is what? Regular rate. Okay, regular rate and overtime rate. And then these are their widgets. Again, same trick lah. Same O, same throwaway widgets we put here. Fatima, Vani, and June. You have the whole description of your matrix already. So, literally, once you have the description, part 3, just write it down. The elements in A, B represent the wages earned by, so what are we, okay, sorry, give me a while, give me a while, Jenny, Fatima, Vani, and June, because 3 different people, so I need to do respectively. Okay? This way. Okay? Any questions, or let me know when you are done? Okay, now last one. Okay, it's a little bit of a multiple thinking process question. So I want you all to try to see whether you all can get for this last part. Okay, part 4. Okay, as you can see, there are certain changes in the matrices. Oh, sorry. Okay. I wait. We still got time. Don't worry. Okay. Sorry. Okay, so just take note, regardless whether it's a little different, maybe for those, awesome. Okay, so let me add out. Regardless whether the question varies a little or more, when they ask you to explain, this technique can always be used. So it saves a lot of time. I'll show you a lot of time. Okay, now, last one. The hourly wages for regular working hours. So this is the part where I say where certain matrices might need to be modified. Okay, so I'm gonna drop down the bomb to you guys and ask you all. So this is the change. Can you tell me, based on this info here, which particular matrix do I need to modify a little bit? Okay, because ultimately I want to calculate the increase. So it's either A or B. I'm going to give you some time. Okay, working hours remain the same, but the hourly wage will increase. So which one am I looking for? Which matrix will be affected, A or B? Okay, any other response? Okay, final answer. Any other response? 5. Let me tell you what you say. Your answer is correct, Tanishka. Okay, Jaylin. Okay, good. But you're getting it. You're getting it. Okay, so I have 2 responses, and yeah, B is the correct answer. Why? Understand your matrix first. Hourly wage increase, right? So B is the previous hourly wage. Hourly wage. I hope you guys are not raging. Hourly wages. But in this case, my hourly rate wage is increased. So therefore, this will definitely be the one that's affected. So in this case, I need to find the increase. How much is the increase? Because I don't want to find the new wage. I'm finding only how much the increase is. Okay, so all you need to do, 20%. Okay, I'm gonna just vandalize this matrix a little. 20% increase is for the first entry here. 15% increase is for the second matrix here. So I'm just calculating for the 20% and 15%. And, okay, maybe I just write down my increase in wages for each respectively will be 4 and 4.5. Okay, take your calculator, press lah. 20% of 20 is 4, 15% of 30 is 4.5. Okay, now let's just try again. How will it make sense for you guys to do it normally first? Because this one has with matrix multiplication. So if got with, no choice lah, have to write down. But suppose again, let's use the previous example. I cancel the statement with using, I cancel the statement using matrix multiplication. Okay, now let me write down for you all. Increase first, okay, just the numbers. Regular working hours is 4 per hour. Okay, and then overtime is going to be 4.5. So let's just do for one person. If I want to find the overall increase, right? Okay, let's say for Fatima, overall increase. Working hours stay the same, but wages increase. Do you agree her overall increase will be what I'm typing out right now? Let me put to the whole class. This is for Fatima. Okay, and then you realize I have Vani and June, so I have 3 separate entries. So in this case, if I were to evaluate 3 separate entries, okay, in this case, to evaluate, say for, okay, Fatima, Vani, and June, same style. My final order to evaluate each of their increase will be a 3 by 1 matrix. Right? Do you all see that? Okay, I'm just evaluate each one of the increase first. Question says for all, but it will be better for me to evaluate each one of them before I go on to evaluating all of them. Okay, now this one, let me finish up a little first. My increase is 4.5. Okay, table just now what I did, you realize from here, based on what I've written for you all, we can just copy and paste the info from the table. What I've written is for Fatima, Vani, and June will follow the same concept. So we can just copy and paste, okay, and ask ourselves. 44, 45, 3, 38, 7. Okay, my final order is 3 by 1. Again, ask yourselves, will this one make sense? Or will this one make sense? I'm gonna give you all the thing again. Okay, let's say this is A. Let's say this is B. Which configuration will make sense to give me a 3 by 1? This time I no label everything. Okay, take some time, respond to it. Okay, this time I think time is almost up. Online, I know your brain or your soul will start to fly out. Okay, so let me help you answer. Okay, so actually the one that work is actually A. Track the order again. This is actually a 3 by 2. This is a 2 by 1. Okay, left and right number matches. Okay, number of rows also allow me to take the two numbers like this. So therefore, evaluating these two numbers like this, okay, so I do row and column. This time I'll skip through the steps here. Okay, row and column, I will have 40 times 4 plus 4 times 4.5. Okay, I'm going to have 178, 45 times 4 plus 3 times 4.5. This is going to be 193.5, 38 times 4 plus 7 times 4.5. This is 183.5. Okay, so this is the increase for each one of them. Why can't it be other one? Okay, take note. I want to have 3 by 1, JD. If I do it the other way, what would be the order first? Okay, always check the order. First thing to note. This one is a 2 by 1. The other one is a 3 by 2. Can I? I cannot multiply. It's a 2 by 2. And also another thing, I cannot even multiply these two in the first place. So even better, I can just take this and code. Don't even need to care. Can see? Yeah. Okay, now all I need to do, these are all their individual increases, right? Logic speaking, if I were to just add all these numbers, 178 plus 193.5 plus 183.5 to give me 555, okay, this will be my final answer already. But God and behold, they say using matrix multiplication. How? Again, understand the context. This is 1 by 1. Okay, one common trick here, I want to have a 1 by 1. So ask ourselves, will it be better for this matrix over here to fit at the left-hand side or right-hand side for multiplication? Right-hand side, I already got 1. So fit this at the right-hand side. Okay, then some of you may ask, okay, sure, very good. You have actually helped me for this part. What's my left-hand side matrix? This is where we can actually use this special matrix just to add numbers together. Okay, remember this matrix, special matrix 1, 1, 1. Basically, all your entries 1. Take your calculator and try. You will get this down. Why 1, 1, 1 and not 2 ones and not 1, 1? Okay, need to fit the number of columns lah. How I get 178? 4 times 40 times 4 plus 4 times 40 times 4 plus 4 times 4.5. Jane. Can? Can see? Can Okay, it's a 3 by 1. Let me shift my start. Yay! Okay, sorry. Okay, now this one don't leave your answer like this. Okay, because a matrix we know is just a number. Write down the final form. As such. Okay, so this part requires us to analyze the matrix accordingly. This way. I think I see your response. Why need 1, 1, 1? Oh, this matrix over here is to show the matrix multiplication because the question specified. As long as you see these three words, need to have matrix multiplication for all your steps. If there's one particular step whereby there's no matrix multiplication, they will not give you the full mark. And the good way, I know certain answer schemes will do it in one step, but for this way, because both steps are matrix multiplying, that's why it is still okay to do it in two steps. And this 1, 1, 1 is really just an explicit form, is just adding my numbers together. So matrix multiply is this, but what we are actually doing is just adding these three numbers together like this, normally. Just add all. So in a way to add all, indirectly for matrix multiplying, we are just doing this. If you got three entries, 1, 1, 1. Got two entries, 2 ones. 1 and 3, 1, 1. Okay? But take note, this is just if I were to just add all these numbers together. Don't have all the weird combinations. Okay? Take some time for you to look at this. Any questions? Down the floor. Okay, sorry for that. Wait, sorry for that. I think give me a moment. I think yeah, okay. Yeah, sorry for that. Any questions down the floor? I think I have mistakenly forgot to yeah. All right, if not, that is actually it for today. So I hope this WA2 revision is helpful for everyone here. So let me just finish up a little promotion site on mine. So if you feel that this class is actually useful, all right, this is actually just a little glimpse of what I can do in the span of 1.5 hours. So in my regular classes, I tend to explain a little bit more and the other tutors as well. So if you want to get more information on the classes, all right, for this one, for 1 second, no problem. Awesome. Okay, so let me go back. So if you want to have more information on my classes dates, all right, feel free to scan the QR code and yeah, that's how you can find more info lah. Otherwise, I hope this has been fruitful for you all. So yes, thank you for staying with me for a good 1.5 hours. All right. So I hope this benefits for you all and I wish you all good luck for your WA2. All right. This is Teacher Jason signing off.